Okay guys, welcome to another video on my channel, and today we're gonna talk about mutation, and next week we're gonna talk about DNA replication because I'm sorry I just learned this in my class and I want to make a video to share with you, also to review my class. So mutation is just it is symbol as an error occurred during DNA replication. So but what is it? So you all know that a chromosome contains like trillion and trillion and trillion, like a power by 10, and you got a chromosome. So if such a long sequence, you can't just ask your body to get it right in the first time. So your body, when they replicate it, they're gonna make some mistake, and yes, they do know how to fix it. There is some like DNA polymerase is gonna go out and recheck everything and fix. But sometimes some of those mutations stays. The DNA just didn't detect it. The polymerase just didn't detect it, or something like that, and it just it just stay there. So next next I'm gonna talk about types of mutation. So first, mutation number one, point mutation. So you see here, sorry if the image seems to be blurry. I found it on Google, so I didn't have much choice. So here, see here, we have the original DNA is right here in the point mutation. This is a very simple mutation that will not affect much. Actually, this is one of the harmless mutation. This doesn't do anything much to your body. Mostly, your body will skip this, or you can still make amino acid like that. Just doesn't affect your body. So this friendship mutation is really, really terrible if it comes to the right place at the right time. So let me see. So we have the first one. You guys, please don't try to Google this sequence because I made those sequence out. So they didn't work really well. I just made this out. Also, I do remember how to make right now. So first, friendship mutation. This is what I call a point mutation. I do give an example right here. So you see, la 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 la. You're gonna copy it right here, but the la 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 la. Except for C, this is a acne, is a cytosine. So in here, we're gonna have a insert and a delete. Let me check. Yes, we're gonna have an insert and a delete. So you see here, the insert over here, so we have this, this, but suddenly we have this, we buy this T, tiny, it's just showing it and it just stay there. So why this insert and deletion is so crucial and so dangerous? Because yes, I'm gonna talk about photosynthesis in my after the next video, but for the basics, you're just gonna know that each amino acid is gonna make three pairs. So each pair of this, that's why we have a space here. Each pair of this is gonna come from one amino acid. But after this, you're gonna see, I'm sorry because I didn't cut this one right, so you're gonna have three, 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 and three. So you're gonna have one extra, one extra, one extra nucleic acid that doesn't fit anything. It doesn't fit anything. So in deletion, this is also the same. Sorry, this one is deletion, this one is insert. When you lose it, it's gonna have one or two nucleic acid that just doesn't know where to go, so it just stay there and do nothing. In this one, this is called the insertion. Just see, I insert the T, the tiny, both of it, I insert the tiny inside it. You see, we have an extra nucleic acid that just doesn't fit. So that's why this is important, that because when it just doesn't fit, it really doesn't fit. You just can make enough amino acid that you need, that your body needs. So, never. These two are just minor. It's just happen from finding some in a few nucleic acids and just have one nucleic acid chain. These two boys have like one or two nucleic acid chains, but it doesn't affect much. But these, you can see, I have my DNA mutation and chromosome mutation. This is a lot of DNA. This is just a little bit of DNA. So, duplication. See, for example, I have this sequence right over here, okay? And this is just for an example because I can write a whole chromosome. Like I said, because I have a trillion and trillion and trillion of DNA of nucleic acid like this. So this one, right? Imagine this one. It's a whole set, and you see in this duplicate is duplicate one part. So imagine that it duplicate the G, the guanine, adenine, and cytosine. The adenine, thymine, and thymine, and this one the cytosine, thymine, and guanine, thymine, adenine, adenine. This one is get duplicated, so we have two of this, which can really affect our body function of making amino acid. So yes, really controversial. Like this one also. Delete area. Imagine this. Okay, is amino acid. Suddenly I delete this one. ATTTAA. TTTAA. Sorry. It means that we got less of something. If you just got less of one base pair, which is free nucleic acid, you're gonna get some really bad trouble because yeah, you don't want to miss everything. So type 3 inversion. Let me explain this. So yes, I'm gonna sketch you that the next video I'm gonna make about DNA replication, and the next after next I'm gonna make about protein synthesis. Sorry, I didn't get it into like a series from small, from large to small. I'm so sorry about this. So you know, if you guys know about the prime and 5' and 3', you guys know that DNA they replicate from 5' to 3'. This is what they call semi-parallel because it go the opposite direction like this, like 5', 3', and 5', 3'. Opposite but parallel. So imagine this end is 5', so this over here is 3', 3', 5'. So this one is go from 5' to 3', and this one goes from 5' to 3'. But it flipped. See, it flipped from here up to here. This is a mistake usually made by in the DNA synthesis. Uh, the synthesis in this phase, and usually made by DNA polymerase. So this is it is very important because if you flip it, a lot of it's gonna make a lot of problem for your cell and the making of amino acid. And next, the last one, chromosomal translocation mutation. This is actually it happens in my my mitosis, believe. Yes, the making of sex cells. So see here, actually normal chromosome don't supposed to do this one. They're supposed to say stay where they are, but sometimes they just flip genetic material like this. So yeah, it's gonna have a lot of problem. But actually, your body do have something to fix these things. So after you donate everything, the DNA polymerase is gonna go back and recheck everything. But sometimes, like I mentioned in the beginning of the video, it doesn't. It's just sometimes it doesn't count everything. It just sometimes skip or some stuff and it's just mutate. Actually, your body mutate like this one, and this one, like every single day. But the rate of mutation, I do mention that in my last video about my cancer, is the rate of mutation will increase if you are your if you are you sorry, what do I call it? You have extensive exposure to radiation and chemicals like smoking, drinking wines and beer too much. Don't get me wrong. Wines and beer are actually good for you if you just like drink 1 cup and then 500 milliliters per day. But too much of that will give you a real problem, including mutation like these. So mutation is caused by excessive exposure to radiation, smoking, and exposure to chemicals. So please don't get into it because I have a life and I need to die soon. So thank you everyone to watch this video for me. Don't forget to like and subscribe for me, and I will see you to the next video.